Alright, next status update here. So I already wired up the 5-volt boost and got that working and was very, very happy that that worked well. And that was, playing around with coming in from the USB power or a LiPo that was soldered in for now. This will be a connector eventually, obviously. So the next part was to deal with the LiPo itself, so the whole power regulation system. So this chip right here, 73871, fantastic little chip. It's the older sibling of the 73831. It's a little more powerful and it does load sharing. So with this chip in place, I can drive the system off of the rechargeable battery, or I can plug in 5 volts and while I'm charging the battery still be pulling 5 volts onto the system bus from here. So it does that automatic load sharing, which is great. Except that, after I put that chip in, put in the few supporting components around it, and fired it up, when I would plug the system in, it would work for a few minutes, and then it would just like die. And I wired in the ESP connector, so I have a little ESP01 here, and if we put that in place, that will let us drive a Wi-Fi in and out system. So so it was working, but it was flaky, right? Something was weird with the power. The other thing is this regulator. It's got a little PWM system, and there's a big inductor on there, and made this horrible high-pitched whine that would actually get worse when you try to reset the Wi-Fi connection. So that's usually telling me, hey, there's something wrong. There's a high resistance path somewhere, a lot of current coming through, something going on like that. So started looking at this chip a little, and this is one of these little 20-pin QFNs, so there's no leads on the bottom that stick out to the side of the package. They're really just straight underneath the package itself, and those are a little tricky for me to solder. Now, when I first started playing with the 6050 accelerometer, I was really careful about soldering these QFN packages, and now I've gotten kind of lackadaisical about it. So turns out I was doing a pretty sloppy job soldering that component in. So started looking underneath it and decided, yeah, some of those connections don't look good. So went ahead and resoldered it, and put down some solder paste, way too much solder paste. And my problem with the previous chip had been too much solder paste in the middle, so the chip was basically floating above the contacts. So cleaned it up, put a new chip in. I think I still had too much residual solder on the pad because this was not doing that, very satisfying self-aligning thing that you normally get with these devices. Until the very end, I got a little bit of a wiggle there, so seemed like it was doing the right thing at that point. And then just kind of pressed it down to try to make sure that it was making good contact. Cleaned up the solder bridges on the side, of course, and that seemed to work pretty well. So, powered it up. Power is nice and solid, no problem at all. Next step was to check the battery system itself. So that's when I wired up the LiPo, and that's just going out to a breadboard right now so that I can swap parts in and out. So hooked that up, plugged in the USB cable, and unfortunately all 3 of my LEDs were now lit. This is power ground, this is indicating a charge, and this is saying that it's done charging. And all 3 of those were lit. So what's going on with that? Well, if you go into the data sheet, and you really want to know your data sheets on these components that you work with, these 3 indicators, right, when you're charging, these 2, power good and status 1, should those LEDs should be lit. So they're either high impedance or they're connected to ground. So you hook the other end of an LED up to 5 volts through a resistor, and you put the cathode into these pins, and when it's charging, whether it's preconditioning in the constant current or the final constant voltage stage, the power good light should be on, the charge light should be on. When it's finished charging, the charging light goes off and the done light comes on. So stat 2 is done, stat 1 is charging. What does it mean if all 3 are on? Well, it means either a temperature fault or a timer fault. And those are the only conditions under which all 3 LEDs should be on. So I double and triple checked the wiring, right, to make sure this was all good. I swapped out my blue LED because that has a bigger voltage drop. I tried all these goofy things. It could not be a timer fault because this chip ships from the factory with a 6-hour timer, and you know, if I just plug it in, that shouldn't be expired. So it had to be a temperature fault. So where does that come from? Well, if you look at the application diagram, this is basically the way that I wired this chip up. There's a thermistor, right, a 10K thermistor coming in on pin 5. That's the thermal regulation pin. So what the chip does is it puts out a 50 microamp current on this pin, and then it monitors the voltage. And the voltage has to be around half a volt. So if you put a 10K resistor in here, you get half a volt at this point. And then as the temperature changes, this resistance will change, and eventually the voltage will go out of range. The chip will cry thermal fault, and it shuts down. So I had a 10K in there. I've got a, you know, good old thermistor. So it's this little chip right here is this temperature sensitive resistor, and you know, that was measuring a nice solid 10K. But when I measured the voltage at this end, it was 0. So what does that mean? It doesn't have any current going through the chip. The only explanation I could find for that was I must not be connecting to pin 5. So I put the board under the microscope and looked really closely at pin 5 and found what looked like a bit of a gap. It should have been connected underneath the chip, but I took a soldering iron, didn't use a lot of flux, just got the iron really wet, splooged some solder onto that area of the chip, and sure enough, it started working. Plug in the USB, and I had power good and charge turned on and done turned off. So now it's in the charge state, so that's good. Next thing, I left it run for, you know, a few hours, and the done light never came on. Now with battery connected through, you know, proto board and long wires, sometimes you disconnect it, connect it again, the done light goes on because you got lots of, you know, capacitance and resistance here. That wasn't happening. So so again, you go to your data sheet, and this pin right here, prog 3, pin 12, that's controlling when the system goes to its completed state, right? So by changing the value of this resistor, you can say how much current indicates that we're done charging. So this is a cool little chip, right? All these charging systems are pretty sophisticated. They basically go through a constant current phase to really bump up the charge, and then when you get close to fully charged, they switch to a constant voltage mode. So this will hold my LiPo at 4.1 volts, and while it's holding at that voltage and the battery's getting more and more full, the current that's being sent to the battery starts dropping, right? And so how low should it drop before we say it's done? Well, if you do the math, and there's equations in here for setting this up, nominal cutoff point would be 20 milliamps. So by putting I think it turned out to be a 10K resistor here, 20 milliamps, it should cut off. Well, I measured the current going into the battery, and it was in the microamp range, so something was wrong. So same thing, went back to the scope and looked at pin 12, which is, you know, back here. And yeah, it didn't look quite like the solid connection I was hoping. Threw a little more solder on there. That worked great. So now it's working great. It charges correctly, and when the battery is full, it switches to done and shuts down the charging system. Alright, so what does this mean? Well, I can plug my USB cable in, and you know, I've got my battery fully charged, so the done light is on. And I can come over here and I can run my favorite terminal program, and you know, I'm connected to the system. That's all working great. So that's all good, but what I can also do is I can flip this Wi-Fi switch, and when I do this, you'll see some lights over here on the ASP flicker for a moment, and then you'll see this blue light flick once more. That's the connection signal, right? And so now at this point, my serial communication is no longer connected, but I can telnet into this machine, right? 192.168.0.88 port 8081, and I've got, you know, full access here through the Wi-Fi. And there's a little reconnect button here. If I hit that, you'll see that light flicker, and then it'll blink once more, and that's reestablished the connection. And so my connection got closed here, right? But I can telnet in again, and there we go. And then if I turn that off, So let me get out of here. Let me do my TIO again. So my TIO is disconnected. So I'm going to flip this off. And now if I come back in, I'm back to communicating through the serial line. So so I have the choice of either wireless communication or, you know, wired through the USB port. And if I, you know, completely disconnect this so that it's strictly running on the LiPo, but I turn on the Wi-Fi, right, then I've got my wireless communication going. So that's basically the current status of it. So I think the power system is working well, the rechargeable battery management is working well, and the ESP01 wireless connectivity is working well. So what's left, really just solder up the remaining components. So about 40 LEDs, some various push buttons, the 2 banks of switches, throw it in a box, and we should be good to be playing with this. All right, cool, thanks.